Happy December. Crazy. Okay. All right. Where did November go? It just flew. We are in the 3.6 notes, and we are going to finish it up with just a couple problems here. So this one says, pictured below is some function f of m. Complete the chart below indicating just the sign, positive, negative, or zero, for the value itself, f of m, for the first derivative and for the second derivative at each of the indicated points. Okay, so they kind of labeled this for you, A, B, C, D, E, F. Oh, just kidding, there's no E. They skipped E. So looking at just the function itself, if I start here at point A, obviously, you know that value is lying above my x-axis. If I were to plot that point, these are all in the first quadrant, so all the x and the y coordinates are going to be positive. So for all of those points, I mean, we can fill this in right away. I'm probably going to use different colors and stuff, but all of these values are lying above, well, I shouldn't say my x-axis. According to this one, my m-axis. So those are all going to be positive. Positive, positive, C, positive, B, positive. Okay, where it gets a little bit trickier is looking at its first derivative and second derivative. So again, making those connections here. The first derivative, we're essentially looking for the slope of the tangent line at that point. That's what the derivative is, right? Or if it's like decreasing at that point. So what do you think for A for the first derivative? Positive or negative there? Would that tangent line be a negative slope or a positive? Negative, right? It's decreasing there. That's what the first derivative tells us, decreasing. Let's go through and do all our first derivatives. What about at B? Positive, negative, or zero?
Zero.
Zero, right? Horizontal tangent, zero. All right. We'd also call that a critical point. C. Positive, negative, or zero? Positive. It's increasing. All right. D. I see I have another critical point, or we could classify this as like a relative extrema, a relative max here. Another horizontal tangent. That's zero. All right. Last one. E. Oh, gosh, I keep saying that. Not E. They just throw me off. F. Yep. Negative. Good. Negative. Okay, that's what the first derivative tells us. Where it's increasing, decreasing, or think of what the derivative means. It's the slope of the tangent line at that point, the instantaneous rate of change. Okay. Now let's go through and discuss the second derivative, which tells us concavity. So at point A, is my curve concave up or concave down? Up. Concave up like a cup. So would that be a positive, negative, or zero second derivative? Positive. Good. Yep. Positive. Concave up. Point B. Concave up or concave down? Still up. Still positive. Still concave up. C is an interesting one. It looks like it's changing concavity right at that point, right? It's all the way concave up, and then all of a sudden at some point, which we're thinking it's about around where C is, now it's switching to concave down like a frown. So we call this point of inflection, or inflection point, either of those, which means the second derivative would be zero. Point of inflection. Isn't this a fun little thing I found on the internet? All right. And then from here on out, at point D, we can see it's now a frown, so it's concave down, meaning my second derivative would be negative at both D and F. Good stuff. Okay. I love when these don't work. It's really fun for me. Whatever. Negative. Okay. The next question is the first question on your homework. So I'll pass out the worksheet. If you want to fill it out in your notes, I just screenshotted it. And then do it on your worksheet too. If you just want to do it on your worksheet, it doesn't matter to me, whatever you want to do. But this is basically your homework for 3-6. There's no book work that goes with this lesson, and I just want to do the first problem with you to make sure where you kind of know what we're doing. And it's very similar to those ones that I had you like try in the 3-5. No, just kidding. 3-4 book assignment. Those last couple of problems, but they're just a little bit more intense, and then they also tie in like second derivatives. Okay, so you can see I have 4 problems just like this where you're going to sketch the graph of the original function that has all of these properties listed. So some stuff going on about the second derivative, the first derivative. So you have 4 of those, and then number 2 is just a little application of when you're given like the graph of the derivative. I don't know why that's number 2. That's just me throwing problems together that I find. Okay, so I'm obviously going to do this one in the notes, but if you want to do it right on your worksheet, you can decide that. So we know, first of all, that it's continuous and differentiable for all real numbers. So there's no like discontinuities, there's no corners, cusps, vertical tangents, or anything like that. No asymptotes, continuous and differentiable. All right, let's read this first kind of characteristic here, letter A. F prime of x is greater than 0 on the intervals -3, negative infinity to -3, and 1 to 4. All right, another way to think about that is your first derivative is positive on those intervals, meaning your function's increasing. That's what the first derivative would tell us, meaning that's increasing. Oh yeah, this is like a good, helpful little chart too, right here. We know it's increasing if the first derivative is positive. That's what it tells us about the function. Letter B says your first derivative is less than 0, or you can think it's negative. On the intervals -3 to 1 and 4 to infinity. Okay, so when my first derivative is negative, that means I'm decreasing. Okay, so right now I'm kind of just going through and making the connections of what this means about my graph, and then I'll tackle like actually sketching it. Then they jump to second derivatives. So remember, second derivatives, that's going to give us our concavity. So our second derivative is less than 0, that's negative. Negative on those given intervals, which means it's concave down there. Concave down. And then I'm on letter D, says your second derivative is positive or greater than 0 on that interval, which means it's concave up there. Okay. Then the last kind of piece of information, they say f prime of -3 is the same as f prime of 4, which is 0. So that means I'm going to have a horizontal tangent. I'll use red. Horizontal tangent could be relative maxes and mins. We're not quite sure. It depends on if it switches sign at that point. But we know that the slopes at those points are 0, so it's going to be horizontal tangent. So it could be an extrema or it could be something like this. It depends on if it's like increasing to the left and to the right. We just know that there's horizontal tangents. That's what that's telling us. When our second derivative is equal to 0, that means we could have a point of inflection. And it changes concavity. So let's label that. Could have a point of inflection here. Kind of depends again where my concavity changes. Okay, so now that I've kind of broke down what that's telling me, the next thing I kind of do is like, I like to split up my graph with like just like dashed lines at all these like different changes in the intervals. So it's like doing something all the way from negative infinity, and then I see -3. So I kind of just like to do this and just kind of like almost separate my graph off. It's just easier for me. If you don't want to do it, you don't have to. Then I see my next interval. If I'm just looking at the increasing and decreasing, it's going everywhere from -3 to 1. It's doing something else. And then from 1 to 4. And then 4 to infinity. So that's kind of where like the increasing and decreasing switches up. Now I'm also going to look at these intervals for concavity. So I know it's concave down, everything from negative infinity to negative 1. So I'm going to draw another dash right here at negative 1. Because then my concavity switches to concave up from negative 1 to 2. I'm going to draw another dash at 2. And then 2 to infinity. Okay, so that kind of just separates things off, and it makes it a little bit easier, I think, to draw in your sketch. Okay, so then I kind of take it like piece by piece, and I like apply basically these 4 criteria. And you can draw this in your notes too. So we know for concave up, if it's, which way do I want to draw it? If it's decreasing, it would look like this. Decreasing would look like that, concave up. Increasing, it would look like this. That's for concave up, like a cup. If it's concave down, increasing would look like this. Decreasing would look like this. Those are basically like the 4 you kind of have to know. And then from there, we can just kind of tie in where the horizontal tangents are and make sure our point of inflection matches up with after we draw these sketches. Okay. So I think I'm just going to probably use blue for the increasing and then just apply the concavity. So I know it's increasing everywhere until we get to negative 3. And I know it's concave up. Nope, down. Concave down. Concave down from negative infinity all the way to negative 1. Okay, so let's just do this first chunk of increasing from negative infinity to negative 3. Negative infinity to negative 3. But concave down would look like this piece. So it would be something like this. And I just do it down here, and then eventually I'll put it up here once I get a visual. So concave down, increasing from negative infinity to negative 3. Okay, so I thought this was supposed to erase it, but it never works. So I kind of took care of that interval. All right, now it switches to decreasing from negative 3 to 1. But remember, it's only concave down until we get to negative 1. So basically at this next chunk here from negative 3 to negative 1, it has to be decreasing, concave down. So concave down, decreasing, it's going to look something like that for the next chunk there. All right, so we have that interval taken care of, the one where it's concave down. Now I'm at negative 1. I picked one of the harder ones to do together too. So now from negative 1 to 1, I'm still decreasing, right? I'm still decreasing, but now I'm changing to concave up. Because I know from everywhere from negative 1 to 2, I'm now concave up, but I'm still decreasing. All right, so decreasing stops at 1. That's why I have this little tick mark here. So I need to do decreasing concave up from negative 1 to 1. So it's going to look, and you don't have to match up your graph quite yet. It's going to look something like that. Okay, so that took care of my decreasing. So it's decreasing from negative 3 to 1. Now I'm still concave up on this next little chunk from 1 to 2, but now I switch to increasing. So concave up, increasing is going to look something like that, just on that little interval. We don't really know how fast. This is just a sketch. I also like this example because, look, we've already used all 4 really possibilities in just this small chunk. All right, that took care of our concave up now. So now the rest is concave down from 2 to infinity, but I have to apply in when it's increasing and when it's decreasing. All right, so it's still increasing from 1 to 4, but now I'm concave down, so it's going to look like that chunk. So it's going to switch to something like that. That took care of my increasing, and now from 4 to infinity, it's decreasing, still concave down. So it looks something like this. Decreasing, concave down. Decreasing, and that took care of concave down. Okay, so that just gives us a little visual. And then you can essentially really like draw it anywhere you want on your graph. We do have 2 points that are given to us. So we have the point -1, 3. I'd plot that point right there. And we have 2, 4. So I do know that my graph needs to pass through those 2 points. Those are the only 2 points I'm given. Sometimes you're given points, sometimes you're not. And that makes sense where these points are because that's where my concavity changes, right? Look at here. I go from concave down. Now it's concave up, then back to concave down. So it makes sense that those are where my point of inflections are. It also makes sense that my horizontal tangents here are at -3. That looks like it's going to be a horizontal tangent. Looks like it's going to be a relative max. And at 4, another relative max. So again, that part kind of like makes sense too. So then from here, you just really sketch it. I'll use a different color here. Let's do one of these. Let's do green. So again, doesn't really matter where, but we do have to pass through this point. So I'm probably just gonna start pretty high here because I know it has to be concave down increasing, horizontal tangent, concave down decreasing, has to pass through this point. Now it switches concavity. Now I have to do concave up, decreasing, switches to increasing, switches concave down, horizontal tangent, something like that. I could have probably made this a little bit better. Something kind of like that. And again, yours might look a little different than the person next to you, might look a little different than mine. But let's add arrows into our graph. And then I always just kind of make sure after I do these that it does indeed like match all this criteria. So let's first check the increasing intervals, and I'll kind of just dash these with blue. Is my function increasing all the way from -infinity to -3 and from 1 to 4? Yes, it is increasing there. Okay, we got that. This is just me kind of double checking. Is my function decreasing from -3 all the way to 1 and then from 4 to infinity? Yes. All right, so my first derivatives all match up really well. Am I concave up? Oh, concave down, sorry. Concave down is my next one. Am I concave down from -infinity my concave down from -infinity all the way to -1 and also to infinity. Yep, that looks good. My concave up in between there from -1 to 2. Yep. Does it look like my derivatives, my instantaneous rate of change at -3 is 0? My horizontal tangent? You betcha. What about at 4? Yup, that looks good. Does it look like I have a point of inflection, my concavity changes at -1, 3 and at 2, 4? Let's take a look. 2, 4, my sketch maybe isn't the best. Again, it's just a sketch. You don't have to know exactly. Yep, it does. All right, so that's kind of how I tackle those problems. And you have 3 more to practice. Any questions on that?
So is there not a horizontal tangent at?
There could be. There is in our case because it has to at some point change from. It just didn't list that on there. And it might not always like give you all criteria, you know, but we know that there has to be a horizontal tangent because it's differentiable there and it switches from decreasing to increasing. Good question. I'm trying to think of some of the other criteria. There's one where like One's differentiable except at x equals 0. I think that's the next one. One, they give you an asymptote and a couple like x-intercepts and y-intercepts. They give you a couple points. So I posted like my sketches on Google Classroom. I'll just pull it up quick. Because obviously there's no like really answer key for this. Because it's not from the textbook, and like I said, there's more than one way that you can kind of like sketch it. So here's the one we just did. Here's just kind of like my work down there. There's like just like my notes to myself. So you can kind of just see if like your sketches look similar. And then this one, there's actually like correct answers, but you do draw in the sketch as well. So, okay. So that's that assignment. I'm going to stop this recording really quick. That's 3.6.